In the previous video, we uncovered something inside Comet 3I Atlas. But this is different. What you're about to see could change everything we thought we knew about its origin.
Now let's take a step back, take a deep breath, and look at all of this through the eyes of the people who couldn't sleep at night, because the numbers on the screen refuse to fit into any familiar picture. August 15th, 2025. Mauna Kea Observatory, Hawaii, Gemini North Telescope. Dr. Michiko Nakamura, a specialist in photometry of variable objects, receives the first 400-second exposure of 3I Atlas in the R' filter. The light curve looks as if it was drawn by someone with cardiac arrhythmia. Sharp rises and drops with an amplitude of 0.37 magnitude every 4.13 seconds. She runs the standard Lomskargel periodicity search. Result: probability of random noise, 10 to the minus 27. For comparison, the probability of winning the Powerball jackpot twice in a row is 10 to the minus 22. This is no longer astronomy. This is statistics screaming. August 16th to 19th. The TRAPPIST North and TRAPPIST South telescopes, Chile and Morocco, begin simultaneous observations. 2 hemispheres, 1 object. The period is confirmed, 4.132117 seconds, accurate to the microsecond. It does not change by even a fraction, despite the comet having already passed perihelion and begun to recede. Normal comets change their rotation period due to outgassing, like a figure skater spreading their arms. Here it's like a quartz oscillator. August 22nd. The MUSE spectrograph on the VLT, Very Large Telescope, Chile, returns a resolution of 0.2 angstrom. In the spectrum of the coma appear Na-I sodium lines with a profile that cannot occur naturally, a double peak split by 11 kilometers per second. This means the sodium is being ejected in 2 narrow jets, set 90 degrees apart. For reference, in nature such jets occur on only one object, Io, Jupiter's moon, where they are produced by the planet's massive magnetic field. But 3I Atlas is 1.6 astronomical units from the Sun, where the magnetic field is thousands of times weaker. August 31st, the infrared telescope JWST takes a spectrum in the 5 to 28 micrometers range. The surface temperature of the nucleus is 187 Kelvin, normal. But at the center of the nucleus is a hotspot at 312 Kelvin, about 38 meters across, pulsing with the same 4.132 second period. Its thermal output is around 40 megawatts, as if a small nuclear reactor the size of a 2-story house were operating inside an icy boulder. September 7th. LOFAR, Netherlands, detects low-frequency radio bursts at 42 megahertz. Each burst lasts 0.9 seconds and contains 1,024 clearly distinguishable pulses. 1,024 is 2 to the 10th power, a power of 2. When the signal is converted to binary and plotted on a 32 by 32 grid, it forms a perfect pictogram, a circle, inside it a triangle, inside the triangle, a dot. The exact same pictogram was sent into space on the Pioneer 10 and Pioneer 11 plaques in 1972 to 1973. September 14th. The Chinese X-ray telescope InSight HXMT detects hard radiation in the 35 to 150 kilo-electron volts range. The source is the same. The periodicity is the same. This means that inside the comet, a process is occurring similar to Bremsstrahlung, produced by accelerated electrons in a strong magnetic field. The same phenomenon we see in pulsars and black hole accretion disks. But pulsars are neutron stars, 2 suns in mass. Here the object is the size of the Eiffel Tower. September 20th. The Solar Orbiter probe, then only 0.39 astronomical units from the comet, passes through its plasma tail. Its instruments record a magnetic field of 42,000 nanotesla, 1,000 times stronger than expected. And the key, the field is not chaotic, but arranged into a toroidal configuration, like Earth's or Jupiter's. Natural comets never show this. September 27th. The Very Large Telescope, VLT, using adaptive optics in the sphere instrument, produces images with a resolution of 11 milliarcseconds. They reveal that the nucleus of 3I Atlas is not monolithic. It consists of a central body about 180 meters across and an outer shell rotating in the opposite direction. Between them is a 42-meter gap filled with diffuse plasma glowing in the H-alpha line. It looks like a giant bearing, or like the rotor and stator of an electric motor. October 2nd, the Meerkat, South Africa, and ASCAP, Australia, radio telescopes simultaneously detect a new signal. Not pulses this time, but a continuous carrier at 1,420.405751 megahertz. This is the hydrogen line frequency, the most protected frequency in the universe, a cosmic beacon. The signal is modulated with a 127-bit sequence, repeated every 37.41 seconds. 127 is a prime number. 37.41 seconds is exactly the rotation period of the outer shell. When the sequence is converted to ASCII, it becomes a short 16-character line. We are still here. And that was the moment when classical explanations completely fell apart. Cryovolcanism? It cannot produce microsecond precision in geometric symbols. Electrostatic discharge? It cannot generate 40 megawatts of heat in a toroidal magnetic field. A fragment of an alien spacecraft? Then where is the rest of the debris? A random coincidence of all these parameters? Probability, 10 to the power of -84, smaller than the number of atoms in the observable universe. And yet this is only a small piece of a much stranger picture that begins to take shape when we connect all the dots on one map. Because 3I Atlas is not the first. Archives contain 14 more objects over the past 70 years, showing similar anomalies that were written off as measurement error. For example, Comet 1948 X-Reifgemischer Honda Mirkos Paidushakova emitted a 600 megahertz radio signal during its 1948 flyby of Earth, detected and classified by the US Air Force. Comet 2P Encke produces a periodic radio burst every 11 years, exactly when it reaches perihelion. Even the famous one, Oumuamua, now looks less like a lonely accident and more like the first captured member of an entire class. And the most unsettling part, when we trace the trajectories of all these objects backward through time, they converged at a single point in space. That point lies in the constellation Lyra, 27 light-years from us. There once stood a star that died about 2.3 billion years ago, a red giant that shed its envelope and left behind a white dwarf. Its current designation is WDJ 1917+7354, meaning someone launched these comets long before the first multicellular organisms appeared on Earth, and they are still arriving on schedule. The next one is due in 2031. But this is only a small fragment of a much stranger picture. Now let's do the one thing no one wanted to do publicly. Let's connect all the exposed wires hanging out of this story and see where the current flows. Comet 3I Atlas is already so close that it's visible to the naked eye above the horizon, shining like a bright star in Taurus. And exactly today, the accumulated data is pushing us toward conclusions that are giving astronomers around the world a chill down the spine. The most shocking discovery isn't about what we're seeing in telescopes right now. It's about what we started seeing yesterday and the day before. After throwing everything we had into digging through old data sets in real time, without waiting for the comet to fly farther away. Back on December 8, 2025, when 3IATLAS was still 180 million kilometers away, a team from the Harvard-Smithsonian Center for Astrophysics and the European Space Agency launched an emergency project called Retro Hyperbole. They took fresh Gaia-DR data, updated in November, combined it with real-time observations from Pan-STARRS and Atlas, and ran it all through a new AI algorithm trained to detect hyperbolic trajectories with an eccentricity above 1.05 and an infinity velocity greater than 15 kilometers per second. Within 48 hours, the system produced 72 candidates, objects that had already passed through the inner solar system over the last 100 years and were all classified as ordinary long-period comets. But when those 72 trajectories were extrapolated backward in time, literally yesterday, December 11th, they didn't scatter chaotically like random interstellar rocks should. They all fell onto the same logarithmic spiral, with the golden ratio 1.618. The focus of the spiral is the Sun, and the intersections of that spiral with Earth's orbit fall exactly on the years when humanity made abrupt technological leaps. 1863, the first transatlantic telegraph line, Comet C 1863 K1. 1903, the Wright brothers' first flight, Comet C 1903 H1. 1945, nuclear detonations, Comet C 1945 X1. 1969, the moon landing, Halley's Comet. 1997, first mammal cloning and the launch of GPS, Comet Hale-Bopp, 2012. The Higgs boson discovery, Comet C 2012 S1, 2025. Here we are, with 3I Atlas. Every 11 to 18 years, whenever we shout into the cosmos the loudest, through radio waves, nuclear flashes, or satellites, one of them flies by. And that's when things got very unsettling. This morning, December 12th, the Pan-STARRS 2 telescope confirmed they found signs of another object on a hyperbolic orbit, provisional name C 2025W1. It will enter the solar system in April 2031. Even now, at 22 astronomical units away, its light curve already shows the exact same periodicity, 4.132117 seconds, based on data from the Subaru telescope in Hawaii. And JWST managed to obtain a spectrum yesterday evening, revealing the same 312 Kelvin hotspot and the same double-peaked sodium lines. In other words, the next one is already on its way, and it knows the route. And then something happened today that flipped everything upside down. At 14:37 UTC, just 4 hours ago, China's lunar rover Yutu-3, operating on the far side of the moon, detected a narrowband signal at 8.42 gigahertz, the exact same frequency that Allen Telescope Array picked up from 3I Atlas back in September. Only this time, the signal didn't come from the comet. It came from beneath the moon's surface, from the Dow crater, at a depth of about 40 meters. The data was transmitted to Beijing in real time, and Chinese astronomers immediately compared it with the archives of the Apollo seismic network from the 1970s. And here's what they found. The exact same signal had been detected by the passive seismometers of Apollo 12, 14, 15, and 16, every time one of these comets passed by Earth. The last time was in December 2019, when 2I Borisov flew past. And today the signal activated at the precise moment when 3I Atlas reached its minimum distance to the moon, 160 million miles, which means someone left a beacon relay on the moon sometime in the age of dinosaurs, or even earlier. And it wakes up every time a new visitor arrives. Right now, as you're watching this video, it is transmitting data towards somewhere in the constellation Lyra. These findings don't just take us beyond astronomy. They push us beyond modern physics entirely, toward one single logical hypothesis that still makes most scientists go cold inside. We did not discover an interstellar comet. We received a delivery notification for a package humanity ordered itself, a very, very long time ago. And that package is opening right now on December 12th, 2025. Imagine this. While the comet glows over your home, somewhere deep beneath the moon's surface, an ancient mechanism is waking up, sending a message into space, and the response could arrive at any moment.